اسبيكتس. على الصعيد الاوبريشنال بنحكي عن البروسيس اكسلنس، بنحكي عن البريفنتيف مينتننس والبريدكتيف مينتننس اللي هي ممكن يوظف فيها الاي ار والفي ار. الكلف اللي لها علاقه بالداون تايم للانفراستراكشر اسيت كمان بتقل، بلس بصير في امبروفمنت للريجوليتوري كومبليانس اللي هي نابعه من انه الووتر كواليتي ايشوز بتكون دائما كواليتي اشورد على كل الووتر لايف سايكل، ستارتنج من الجراوند ووتر وحتى التاب زي ما بيحكوا. على الفاينانشال ليفل اكيد كلف التشغيل والصيانه بتكون اقل. بنحكي مين اللي في الاردن احنا عندنا اشكاليه كبيره في الانرجي بيل، فاكيد التحول الرقمي بيساعد على الاوبتمايزيشن للريسورسز وذير باي بنعكس في كلف الكهرباء ومختلف الكونسيومبلز اللي بتلزم الووتر تريتمنت وشبكات المياه والصرف الصحي. طبعا بنحكي عن انكريز في الكابيتال افشنسي اكيد متزامن مع الريفينيوز. طبعا احنا هون بنيجي بنحكي في الاردن بشكل رئيسي، كان راح نحكي بالسلايدات الجاي عن التدخل اللي صار في موضوع الميترنج واللي بيساعد على انه يحافظ على جروث بالريفينيوز بشكل مستمر. واخيرا الريسيلينسي اللي هي بتساعد الكوميونيتيز على انه يكون انجيجد اكثر، بتساعد الورك فورس ديفلوبمنت بانه بتكون افويد للاكسبوجر ريسك، وبتساعد اليوتيليتيز انها تسوق نفسها وتعمل انوفيشن وبراندنج على مستوى ادابتيشن لنيو تكنولوجيز وعلى مستوى سكيلابيلتي موديل لمختلف التكنولوجيات اللي ممكن يشتغل عليها. طبعا هاو ديجيتال ترانسفورميشن اوبتمايز احنا بنحكي عن الريسورسز زي ما حكينا، الداون تايم للكريتيكال اسيتس بقل عندنا، الابستراكشن كومبلينس نتيجه الموديلنج وتوظيف التكنولوجيا والريموت سنسنج بصير عندنا اعلى، الليبر كوست الانرجي اللي حكينا عنها الكونسيومرز في محطات التنقيه وما الى ذلك، بترفع مستوى الكواليتي اكيد لانه الافوردابيلتي والببليك بيرسبشن للهيلث اسبيكت ممكن يوظف فيه البلوك تشين والاليرتنج والسيستمايزيشن. طبعا بتساعد صناع القرار اكيد لانه في عندك تحليل دائم للاوبكس والكابكس، بلس في عندي الجوثرمز واف سيناريوز دائما وابدا شغال على الماشين ليرنينج والليرنينج كيرف بحيث تعطيني اوبشنز اكثر. طبعا كمان بيجي في لينكج على السمارت سيتيز والجرين ايكونومي بشكل رئيسي. احنا دائما بنحكي عن سيرفيس اورينتد مانجمنت، السيركولاريتي، الفوت برنت وما الى ذلك، وتوظيف الانترنت اوف داتا والبيج داتا اللي هو مؤخرا بلش يصير عندنا في البلد. واخيرا الانتجريشن، اكيد الديجيتال ترانسفورميشن بيعمل اوبتمايزيشن على النكسز اللي هي ما بين الفود الانرجي الاجريكلتشر، لانه بعطينا الريال تايم تول تو بلان بلس ديجيتال توين تو سيميوليت الفيزيكال اوبجكت في الانفراستراكشر. الجلوبال باريرز خلينا نحكي عنها سريعا. احنا بنحكي بشكل رئيسي وهي مشكله حقيقيه عندنا في الاردن اللي هي الانتجريشن والكومباتيبلتي مع الكرنت سيتويشن، بلس دائما في كونسيرن على موضوع الهيومن ريسورسز وهاو تو نافيجيت الامبلويز، بلس في عندنا مشكله بالفاينانشال كاباسيتي لانه ما في كلير فاليو بروبوزيشن. بالعاده بيكون في الديجيتال ترانسفورميشن بروجكت او انترفنشنز. في عندنا المشكله اللي كمان السايبر سيكيورتي والداتا برايفسي اللي هي وورد وايد يعني عمان وبعانوا منها، وكمان في موضوع زي قطاع المياه لانه موضوع خدمه حيويه وممكن ياثر في حياه الناس ومستوى الخدمات وياثر على قطاعات مختلفه، فبكون السايبر سيكيورتي الى بعد يعني شوي كريتيكال اكثر. بنحكي عن لاك في التايم والاندرستاندينج اللي هو غياب الاستراتيجيه الواضحه في التحول الرقمي، مع انه عندنا في الاردن وزاره الاقتصاد الرقمي يعني والرياده تبنت استراتيجيه، بس ستيل بدها كستمايزيشن على مختلف القطاعات زي الووتر والانرجي وما الى ذلك. في كمان عندنا لومينج بالديجيتال سكيل جاب، وهاي ممكن موضوع الاديوكيشن انفولفمنت ومؤسسات البحث العلمي تشتغل على سد هاي الثغرات للنكست جنريشن. في عندنا الببليك اكسبتنس والتشينج مانجمنت اللي هو التغيير اللي بيصير دائما في المؤسسات، الكل بيعاني منه نتيجه غياب الكونتكست والرود ماب الواضحه للموظفين للتكنولوجيا، لانه انت بتحكي عن ستافنج وبتحكي عن اكزيستنج انفراستراكشر وبتحكي عن الاورجنايزيشن كاباسيتي تو ترانسفورم بروسيسز انسايد. يعني في كمان عندنا الجانب التنظيمي او الانستتيوشنال اوبستكلز والبيبر وورك، هاي كمان بنعاني منها خصوصا في موضوع البيروقراطيه في بعض الببليك سيكتورز. الليجاسي سيستم هاو تو افويد وابجريد وموف تو سكيلابيلتي موديل، كمان الكل عندنا الخبرات الطويله على كرنت سيستم بجوز بتعاني من صعوبه في التحول بشكل يعني اكسلريتنج شيفت للديجيتايزيشن. ايضا في عندنا مشكله الانفايرمنتال من بعد ثاني، زي ما هي بتوفر بروتكشن وزي ما هي بتوفر اطار تنظيمي لدعم الكلايمت تشينج والفوت برنت، بس كمان في عندنا موضوع الهيتنج والفنتيليشنز والكولينج لهي الانظمه، واللي كمان ممكن يكون في له بعد على موضوع السيرفرات والكلاودنج بحاجه لمعالجه. واخيرا وليس اخرا التحدي الاكبر واللي كمان احنا من الاردن بنعاني منه، غياب الداتا افيلابيلتي، وانها تكون موثوقيه ومعتمده بحيث توظف في موضوع الديجيتال ترانسفورميشن، لانه احنا لما نحكي عن ديجيتال بنحكي عن داتا، وانس انه ما فيش داتا معناته في عندنا اشكاليه. طبعا الدرايفرز جلوبالي ولوكالي ويرفر، يعني في اليوتيليتيز هو الايجنج انفراستراكشر، الهيومن كابيتال والورك فورس ايشوز وتحدياتها، الزياده السكانيه ونمو الطلب على مختلف القطاعات والخدمات. بنحكي عن امبليكيشن للفاينانشال ريسورسز والاوبريشنال افشنسي، بنحكي عن السيرج في الديجيتال والتكنولوجيكال شيفت اللي عماله بيصير في كل القطاعات، سو اتس مانداتوري تو موف فورورد في قطاع المياه. ايضا الانتجريشن والادابتابيلتي، بحيث يكون في صانع القرار عنده قدره على انه يحتوي كل الاف سيناريوز في اليوتيليتي سواء على التكنيكال او على الكوميرشال ليفل. واخيرا الامرجنسي ريسبونس والكرايسيس مانجمنت زي ما صار معنا في موضوع الكورونا، وتحقيق الاس دي جيز اللي هي اهداف التنميه المستدامه. سريعا بالاردن عندنا يعني ترابه بالمشكله الاساسيه او الاوتلوك الاساسي، انه احنا تقريبا نص المياه عندنا تستخدم في الاغراض الزراعيه، بلس عندنا الاعتماد كبير على المصادر المائيه الجوفيه، وكمان احنا يعني نعتبر ليدرز في موضوع التريتد ووتر اللي بده شوي اكسبانشن اكثر. من هذا المنطلق كمان المشكله اللي يعاني منها قطاع المياه واللي راح نحكي عنها هسه، موضوع فاقد المياه والتدهور في موضوع الكميات الهطول المطري نتيجه تغير المناخ والتاثر، سواء المياه السطحيه او المياه الجوفيه نتيجه الريتشارجنج. تقريبا احنا بنحكي عن معدلات فاقد مياه بالاردن تتمحور حول 47% زي ما احنا شايفين، سواء على الفيزيكال او الكوميرشال لوسز. المشكله الاساسيه في البوند العريض السكارسيتي اوف ووتر ريسورسز، تقريبا احنا بنحكي عن اقل من 100 متر مكعب من كميات المياه المتجدده حصة الفرد اللي هي اقل من المستوى العالمي، والكل بيعرف هاي المعلومه. ارتفاع الكلف سواء من الانتاج وحتى التوزيع مرورا بالتنقيه، احنا بنحكي عن تقريبا نص الدرينكينج ووتر برودكشن بكلف اكثر من معدل سعر البيع. عندنا مشروع الديسي اللي تم انجازه من سنوات كمان ينقل فيه المياه مده على طول 400 كيلومتر، وهي اشكاليه كبيره، زي اشكاليه توفر المياه في الزاره في محطه الزاره اللي كمان الديوتر اليفيشن عمالها بتصرف كلف كهربائيه عاليه جدا. فارتفاع الكلف على الانتاج والمعالجه والتوزيع عماله بيخلق مشكله اساسيه في الاردن، فاقد المياه وعدم وجود مصادر مائيه جديده. هلا مؤخرا اجت رؤيه التحديث الاقتصادي للتركيز على بعض القطاعات والثيمات، واحنا هون بموضوع الديجيتايزيشن حبينا نحط ليست اوت سريع بانه احنا بنحكي برؤيه التحديث الاقتصادي عن مبادرات لها علاقه بتخفيض فاقد المياه. في كمان امبروف الافشنسي للانرجي يوز، وهذا برجعنا على موضوع الاو ام في الديجيتايزيشن. في كمان يوتيلايز التكنولوجيكال سوليوشن للووتر سستينابيلتي بروجرام، وفي اطلاق الناشونال انوفيشن سنتر، وفي النكسس كانسل. فكلها بنحكي عن التكامليه وتفعيل دور التكنولوجيا والرقمنه في قطاع المياه. طبعا الستبز اللي في قطاع الاردن تم اخذها جزء منها في بعض القطاعات متواضع، جزء منها يعني سيريس ستبز، بس بشكل رئيسي بنحكي على مستوى اليوتيليتي عن السكاد يوتيلايزيشن. قد لا يكون الفول انجيجمنت لكل النتورك، لكن بنحكي عن الكريتيكال ريسورسز، البرايمري سيستم، وبعض المحطات اللي عمالها مونيتورد حاليا من خلال السكادا. وفي الناشونال ماستر بلان اللي عملت على انها تعمل انفستمنت بريوريتي لموضوع الانجيجمنت والانفولفمنت للشبكات. في السمارت ميترنج بلش بشكل متواضع، تقريبا عن 20% ل 30% من الميترنج على مستوى الكاستمر سايد الكترونيه. بلشنا نشتغل على الاي سي تي والريجوليتوري كومبلينس اللي هي الامور اللي لها علاقه في الباندويث والفريكونسي والويفز اللي كمان بدها ابروفلز. واخيرا بلشت شويه تفوت على البزنس فانكشن زي الاي ار بي موديولز في قطاع الاتش ار، الاكاونتنج، الاسيت ريجستريشن وما الى ذلك. على مستوى الريسورسز بنحكي عن الريموت سنسنج والجي اس انتجريشن، بنحكي عن السيستم تاع الناشونال ووتر انفورميشن، بنحكي عن السمارت ميترز على الابار الخاصه وبعض الووتر فاسيلتيز، واخيرا قدرتنا على احداث موديلنج وفوركاستنج للكريتيكال جراوند بيسنز من خلال انتجريتد ووتر ريسورسز مانجمنت. طبعا في ثيم تحديات شوي كستمايزد لكيس الأردن فيما يخص موضوع التحول الرقمي في قطاع المياه. حبيت ألخصها ببعض الهيدلاينز. بنحكي بشكل رئيسي عن التزويد المتقطع بحد من تفعيل الرولينج اوت لكل التكنولوجيز اكروس النتورك. في عندنا اشكاليه انه دائما وابدا كل صناع القرار والسينيور اوفيشلز عمالهم بركزوا على احداث ثوره في انتاج كميات مياه جديده بعيدا عن موضوع الرقمنه، لانه فيه اولويات بتلعب دور كبير في تلبيه الاحتياجات الحاليه والمستقبليه. طبعا عندنا كمان المؤسسه فيها اشكاليه فيما يخص موضوع الديجيتال ترانسفورميشن، في غياب للثيم او السكيم تاع الشراكه بين القطاع العام والخاص، لانه احنا بنعرف انه موضوع التكنولوجيا والديجيتايزيشن اكثر الشفت تاعه عماله بيصير في البرايفت سيكتور وينقل الى القطاع العام من خلال تبادل وتشاركيه. في عندنا غياب للكاباسيتي بيلدينج والتشينج مانجمنت منتاليتي في كثير من المؤسسات، غياب البحث العلمي والتطوير، وقطاع التعليم كمان يجب التركيز عليه، لانه بنلاحظ دائما في تيبيكال سيلبس تيبيكال ديماند في قطاعات معينه لازم نبلش نشجع موضوع الرقمنه والتحول الرقمي. طبعا جاهزيه شبكه المياه والبنيه التحتيه كمان بتلعب دور كبير في الحد من الانتجريشن للسيستمز، لانه مش اي شبكه بتعمل ادابتيشن للديجيتال ترانسفورميشن تكنيكس او موديولز. بنحكي كمان عن اشكاليه في موضوع التندرنج والبروجكت مانجمنت فيما يخص مشاريع التحول الرقمي، وفي عندنا طبعا اطار التعرفه، واخيرا الببليك بيرسبشن. طبعا وين الاولويات عندنا؟ اولوياتنا نابعه من مشاكلنا. اول شيء على مستوى الووتر ريسورس بنحكي عن توسعه الريموت سنسنج لحمايه المصادر المائيه، بنحكي عن السمارت ميترنج خصوصا عن موضوع البلك كونسيومرز او الابار الخاصه، بنحكي عن الموديلنج للبيج داتا اللي هي اوريدي موجوده بس بدها ستراكشرنج وهندسه معماريه، وبنحكي عن ووتر كواليتي والسامبلنج اللي ممكن تساعد في حمايه المصادر المائيه. على مستوى تخفيض فاقد المياه اللي هو مشكله اساسيه في الاردن، كلنا بنعرف انه الديجيتال ترانسفورميشن ممكن يوظف في السمارت ميترنج والسمارت نتورك اللي بتساعد على انترفنشن زي البريشر مانجمنت، الليكج كنترول، وتخفيض الفاقد الاداري والفني على حد سواء. طبعا انطلاقا من انه نص مياه الاردن مستخدمه في القطاع الزراعي، يجب التركيز على سمارت اريجيشن واللوسز كنترول، لانه شبكات الزراعه في الاردن عندنا مشابهه لشبكات توزيع المياه، بلس على اليوز افشنسي وكفاءه استخدام المياه في القطاع الزراعي. واخيرا على مستوى اليوتيليتي بنحكي عن اسيت مانجمنت، الاي ار بي موديولز اللي ممكن تفوت على الهيومن كابيتالز وعلى الفاينانشال موديلنج. بنحكي عن الفوتره والتحصيل اللي هي اكتيفيتي رئيسيه في كل سيرفيس يوتيليتي سواء كهرباء او مياه. وبنحكي عن توفر الداتا وتوفر دقتها بنسب عاليه ومعقوله تو ستارت وذ. البوتنشل في الاردن اللي بيساعدنا مشان نكون كمان بوزيتيف، في عندنا الناشونال بلاتفورمز اللي هي الاوبن جفرمنت انفورميشن سيستم بلشوا فيها، في عندنا كثير ترانزيشنال انترفنشنز عمالها بتصير وتبنتها الحكومه، الاي بيمنت ميثود والاي سيرفيس فور بابليك عمالها بتصير اكسبتد وسكيلد في كل المجتمعات حتى في الاطراف بعيدا عن العاصمه. الديجيتال انفراستراكشر كابابيلتي كمان تعتبر بالاردن ليدنج مع انه بدها شغل كثير. الفاسيليتيشن والبروموشن اللي متبنيته الحكومه عندنا ومختلف الديسيشن ميكرز، بلس في عندنا الهيومن كابيتال اللي دائما احنا نستثمر فيها ومنوظفها. واخيرا الحاجه الاساسيه لمعالجه تحديات قطاع المياه بتدفع اليوتيليتيز بانها توظف التحول الرقمي فيما يخدم مصالحها على الشورت تيرم وعلى اللونج تيرم. واخيرا الانفستمنت انفايرمنت والتنافسيه اللي تمتاز فيها السوق الاردني. يعني هيك يعني سريعا هون في ريفرنس ليست، حبيت بس احط يعني سياق الامور في التحول الرقمي كخارطه في موضوع الاردن من ناحيه التحديات والاولويات. والشيء اللي انا دائما بحكيه بحقيقه انه واحده من اكبر مشاكلنا انه دائما نستورد الحلول استيراد بقوالب جاهزه. طبعا احنا بدنا العكس اللي يصير. يعني دائما بضرب مثال انه قبل آلاف السنين في منطقه في الحميمه الغربيه في الاردن كنا نشوف كيف الحضارات اللي سكنت هناك كانت تعمل برك بحيث تمنع التبخر، وكيف في عندنا في البتراء او في رقيم موضوع القنوات المائيه. فكل حضاره وكل مجتمع كان حلوله تنبع من مشاكل وتحدياته الداخليه، لا تستورد الحلول بقوالب جاهزه. وبالتالي لازم نشتغل على انه نوائم اولوياتنا ومشاكلنا برياليستيك موديل، بحيث ان نوظف التحول الرقمي مش بانه يكون فانتسي او شو كيس او بس يعني داشبوردز عمالها بتطلع وبتنزل والوان حلوه وكلرفول. لا، بدنا اياها تعالج فعلا المشاكل وتساعد صناع القرار بانهم يعملوا اف سيناريو وفاينانشال موديلنج لكل القطاعات. يعني ان شاء الله ما اكون طولت عليك وهيك، بس حبيت نقدم برزنتيشن بسيط. الله يعطيكم العافيه.
Thank you, Engineer Iyad. This was fruitful, inspired. The subjects are too many. This need, for sure, it needs much more than 15 minutes to talk about all those important issues. Now we move to Mr. Nabil Al-Qadsi. Nabil, please, again, you have 2 minutes to present yourself, 13 minutes to present your presentation. Just allow me to say for the presence that we will have at the end a Q&A time. So anybody who will have a question, just remember it, register it, write it, whatever, okay?
So first of all, thank you, Iyad, for the great presentation. حبيت أعرف نفسي نبيل القدسي، مهندس مدني خريج جامعة دارمشتات بألمانيا، بشتغل تقريبا أكثر من 15 سنة في مجال الواتر مانجمنت، ومسؤول عن شركة نيفوس على بروجكت في أفريقيا وأمريكا اللاتينية. So أظن هذا أقل من 2 minutes. So I would take the opportunity this opportunity to present a case study we have made in Casablanca in Morocco, mainly in cooperation with the maintenance team in terms of leak detection. But the reason why I would like to highlight this method, because it's not a conventional method. This is just a created method how to take opportunity from the existing measurement value we have. You know, every water supplier had a lot of flow meter installed, of pressure meters. And they are still working and measuring, but what to do after 10 or 20 years. So the idea behind this method to create an algorithm or a method to use this database of measuring for pre-locating or predicting leak detection, for example. So the issue in this case was to pre-localization and leak detection in drinking water network by using a modeling-based algorithm. So if we have a leak, the first thing we recognize is a pressure drop, of course, on the network. Now, before starting a leak detection campaign to detect or to look to localize this leak, we start with analyzing the flow into the area or the sector we want to prove. In comparison with the volume coming out from the volume. This is the standard method, which is getting more and more easier by using smart meters, for example. It's easier to identify the volume of the inlet and to compare it with the already consumed or to distribute volume of the water. The second, this is just a hydraulic balance between the build volume and the delivered volume. And according to that, we can more or less approximatively identify the volume of the leak. The second method is of course, to partitioning a zone, the drinking water distribution network to several zones and to prove the zones each separately. Just a second. The third reaction must be to reduce the pressure in term to just to reduce the leak. Of course, this is the first step we do, just to decrease the pressure on the inlet, to reduce the volume of the leaked water. So our approach in this project, this is just things that we do when we recognize there is a leak. Of course, to prove the night minimum is the first step. As soon as we have a high flow on the night minimum between 2 and 4, and the same quantity is appearing also during the day, this is the first indication of the leak, and after that we start, of course, our leak detection campaign. So the aim of this method is to detect and locate the leaks in drinking water, focusing on the resolution of fixed and variable area discharge equation, which is the Darcy equation to calculate the flow, by use of a prediction algorithm with the hydraulic modeling of a geographic information system. So we would use just our existing geographic information system, and to transfer this network to a software called EPANET. EPANET is a free software developed by U.S. Environmental Protection Agency to model a distribution network. It's an open source software that simulate nodes, pipes, pumps, and reservoirs, but also valves. Just to it's a modeling software which is open source, and we can just use. You can get it even on the intranet. So the main idea behind this is just to create a zone. In this case was in Casablanca, in the old city of Casablanca. We created a zone, and we just model this zone and transfer this modeling from the GIS to the EPANET. And EPANET is a modeling software that can even calculate the flow, the pressure, and the nodes, but also the velocity, flow velocity on the network. So the idea is by using this modeling software is to create 4 information. The first one is the distance between a simulation node and the sensor, and the leakage flow. Then we have the emitter coefficient and the pressure at the sensor. So in this EPANET, we have modeled our sector with around 4093 nodes try to simulate a leak by opening, for example, a fire hydrant as simulating as a simulation to the leak. So we have the first step is to transfer the network from the ArcGIS to our EPANET, and to EPANET set below also which guide is software, statistics software, which is called MATLAB, to evaluate and to evaluate and to calculate or to treat the data getting from EPANET. just additional software to create and to treat this information getting from the EPANET. So I would just try to explain this in form of an example. This training data is obtained by using EPANET code and MATLAB as a software to evaluate this information, which is an open source, as I said before, that provide the programming interface to EPANET with MATLAB, and it is it enables us to simulate and plot a leak. There is two ways how to create a leak, for example. The first one is to create a leak or to simulate a leak as a demand or as a consumption volume. Or the second one is to open, as I said, a hydrant where we measure, we install the flow meter and a pressure sensor to determine the volume of the leak and observe how is the behavior of the whole network. So in this case, we have 493 nodes were defined to simulate leak with different emitter. We took, in this case, a 2.8, 1.6, 2.4, and 3.2, which is corresponding approximately to the leak, in this case, 5, 10, 15, and 20 liters. So in the nodes, in this EPANET, we applied a different coefficient, which is corresponding to different rates of leak. So we just made a mix between a minimum of 5 to 20 liter. Why 5? Because this is the minimum we could identify as we have to consider also the error of the pressure sensors and the flow meter in this case. So the system can detect the minimum flow the system can detect is 5 to 6 liters per second, not lower. So we have 49 tree, then we have 3 inlet in this sector, 3 inlet, and we have 4 pressure sensor that permanently measuring the pressure. In this case, we had a measuring interval of 5 minutes, but later it is recommended to take maybe a higher resolution to measure the pressure, just to be able also to consider the pressure variation also in this short interval. But in this case, we used a 5-minute measuring interval in these 4 sensors, and let our system, modeling system working. So we have 493 nodes, and we have 4 different pressure. So in this case, we have for each nodes a simulation of pressure and flow around 19 to 72 simulation. So the idea is just to create a database of pressure and to observe how is the behavior, the reaction of my sector, and record all this information as a library. So in this case, we have a different situation. We have different behaviors or reaction of my sector. And this is the database I would... 2 minutes? Okay. So just, I make it just... So in this case, I have a database, And as long as it's a case is appearing, I know exactly the distance between this leak point to the pressure sensors. So the information also we have in this sensor just to add the information of the maximum, the minimum, and the average pressure on each nodes to my my database. In this case, we have opened an fire hydrant, which we already know the coordinating of it. And we have a flow meter measuring the quantity of these hydrant. We let it around 30 minutes flowing, and the system delivered automatically the distance between this leak point to the different force sensors. In this case, okay, this is just to overcome the next, just to visualize this methodic. So we have a pressure as a reference. We have our simulation results. Then we have the pressure reference leak. And we have a data which is evaluating all this information and detecting anomaly of my system. So if a leak is appearing, the system can detect automatically the distance between this leak and the 4 existing sensors, for example. So the results looked at these, for example. I have the distance from my 4 sensors from the 4 sensors to the leak, and we just draw a circle of each pressure sensor with the delivered distance of it. Just 1 minute, I was to it, and we have already the 4 distance to the existing pressure, and that intersect in many points, and the more intense, the higher intensity of the intersection point is mostly an indication or indicate a higher probability of a leak. So in this case, we just draw a circle around each intersect point, and the highest resolution or the highest intensity of this intersect point deliver or indicate automatically or leads to automatically to a higher probability of my leak. So in this case, we were able to detect the flow or to detect the leak in the area of 100 meters. And after that, we can start using the conventional method like correlator or the acoustic method to identify or to localize exactly the leak, just to avoid additional costs of earth work and so on. So in this case, we now around 100 meters. It's also give us the possibility to handle it faster. So this is the idea. How the idea behind this was just to take opportunities and to take advantage of the already existing measuring value over the 10 or 20 years. So it's not just deleted and to make the server free, but we can also use this existing value also by building an algorithm to detect a leak and describe the behavior of my networks. Yeah. So thank you.
Engineer Nabil, and now move to our next presenter, Mustafa Khan. Again, Mustafa, please introduce yourself in 2 minutes and present for 30 minutes.
Okay, all right. We'll try.
Right.
right. So I am Mustafa. I'm working for Vivavis. We are a manufacturer of products for the energy, automation, and distribution transmission industry. In this case today, I want to give you a little bit brief about what we are able to do with our technology and our solutions for advanced water network management. So my background, basically, I'm an electronics and a communications engineer, and I have done my master's also in business administration from Manchester. I've been working in this industry for almost 10 years, mainly working with the water utilities and trying to solve the problems related to the network management. So what do we have here for you guys today? All right. First of all, I want to set the context a little bit. So I saw that my panelists here spoke a little bit about digitalization and how digitalization is, required, and we are using, some new innovative technologies, for example, machine learning and algorithmic learning to solve these problems. But what is also important is that digitalization does not mean that it starts only with the systems. The digitalization is starting with the people. So it's a complete mindset. It's a complete, let's say, a change in the policies within an organization. And the people who are capable to do this digitalization should be the experts in this network. So when we're talking about water and when we're talking about Vivavis, we are bringing almost, we are in the market since 1975, and we are in this industry quite a few years now. We have a global presence, so we are not looking at this solution, at these problems and trying to solve them locally, but also from a global perspective with over 5,000 clients and more than 150, let's say, projects and experience that we are able to pool together. Yeah. And we are working in the sectors, as I said, water, energy, gas, and so on. And at the end of the day, our goal here is to create sustainable infrastructure for livable cities. That's the goal that we want to achieve. So this is just, I'll just go like 30 seconds with what is our technology and solutions, and then we come to the good part. So we are able to provide you the complete hardware, the automation and the telemetry. So that this means the RTUs, the data loggers, the PLCs and IoT gateways. We're able to provide the communication technology. We are able to provide the software to control it, the SCADA software, or the meter data management, or the energy management software. And then we are able to provide you the advanced network management. So what do you do with this data? How do you improve your network? You want to reduce non-revenue water. You want to reduce leakages. So how can you make these kind of decisions? And that's what we are trying to tackle. So end in end, right from your customer, or let's put it this way, right from your resource to your customer, we are able to provide the technology to maintain that. As I said, we are also doing turnkey projects. So it's not only about providing your solutions, but also providing you a complete knowledge. So we are providing you we have the expertise to do the hydraulic model, to do the maintenance, to do the operation support, and so on. So what are in our context, we say that for the water management, there's supposed to be 5 steps. So number one, you should have a good design of your network, right? So you need to have so most of the utilities do have a GIS system, but these needs to be accurate, these needs to be improved. So that's a big part. So you need to improve your GIS data. You need to, you already have the consumer data, but how do you run the analytics on the consumer data? And then you have the hydraulic models, you have the simulations of how you're going to run your networks. So that's most of the time, 90% of the time, these 3 systems are sitting in different silos. If you want to have a total control over your network, you're going to have a system, or you're going to need a system that is able to bring these systems together. So you need to create synergies between the geographic information system, between the consumer data, between the hydraulic model, and so on. Then of course, we talked about this. You need to measure and you need to control. So you need the infrastructure for that. You need the automation. You need to create the chambers, install the flow meters, the PRVs, the instrumentations, and so on. That's the second step. The third step is, and normally that's what happens, is that it goes then into another silo, is the SCADA system. So you have your network, that is the controlling the network through the SCADA system, but that's again another silo. So as I said, we have the GIS in one silo, we have the consumer data, or let's say the ERP data in another silo, you have the simulated system in another silo, and then we have the SCADA sitting in another silo. And normally, these are 4 or 5 different systems managed by 5 different departments. However, the interconnection between these 3 or 4 departments is at the heart of digitalization in our context. So this is where we developed our advanced network management software, which is sort of like your platform for decision making, for managing, and for operating your network. And finally, we have the smart metering and the IoT devices. So now you say, okay, why don't you put the smart metering maybe in the measurement and control? Well, that's what 90% of the people think about that. But smart metering doesn't solve your problem of the simulation. Smart metering doesn't solve your problem of the GIS data improvement. Smart metering is only giving you the readings of your actual network at the moment. So that's why this is something so smart metering is only, let's say, realizing the information that you already have from your billing systems. Smart metering is going to make it more or less real time. So that's why we put it at the end of the chain. So as I said, our platform here is to bring these 4 or 5 silos that usually exist into one network planner and manager. This is sort of like a tool that we can use for real-time monitoring of the entire water network, from the resources to the consumer area. You are able to integrate this with the GIS system. You are able to integrate this with the hydraulic modeling system. You are able to integrate this with the ERP system. And then you guys might be thinking, okay, why do I need to do this? What is the use for me to do this integration? Well, because there is many decisions, many KPIs that you can create using this kind of synergy. So you can say, for example, what is my consumption per area? What is my consumption per consumer? What is my leakage per kilometer, per hour? What is my leakage per on a weekend? Or what is my consumption on a normal day compared to a festival? Let's say, what is my consumption in Ramadan compared to my consumption in normal days? So this is kind of the information that gives the managers and the water utilities the sort of KPIs that they need in order to improve their network, right? So they're going to look at, okay, if I have this area and this is being fed with such kind of KPIs, how can I improve these KPIs? So you're already setting a target. So you say, okay, maybe Jordan has, let's say, 20 DMAs, Aman has 20 DMAs, and one DMA is doing, let's say, 20% losses compared to another DMA that's doing only 5% losses. So where does the utility needs to act now, right? Probably in the DMA that is having the highest losses. So that's sort of setting the KPIs, setting based on a performance management of the network. And then on top of that, when you have this data, you're opening up the window to the big data. You're opening up the window to the anomaly detection, to do reporting, to do data analytics, to do leakage detection, to create your DMAs, and to support the decisions, whether it is for the quality of the water, or it is about the pressure in the critical points, and so on. So as you can see here, I'm just going to run through this. You can integrate or you must integrate, if you're talking about digitalization, you must integrate your water resources, your water transmission network, your pumping stations, all your assets into your systems. And then integrate this with the existing GIS system. So you have the GI visualization of the real-time operations data on the map. So you can see in real time how is the network reacting. Then for the management, you want to create some dashboards. You want to create some key areas that you want to monitor. So you aggregate the data from the SCADA. You aggregate the data from the simulation. You aggregate the quantifiable measurements at the end of the day for the operators to monitor and evaluate the efficiency of my current operation, my daily operation, my annual operations, and so on. So, and on top of that, we can use additional modules for leakage determination and optimization. So you can look at the DMA pressure, you can look at the DMA flow, you can do minimum night flow analysis, you can create the water balance tables in accordance with the international water standards, the IWA standards. And you can compare this with the operational data. So you have your simulated data, you have your operational data, and you can compare your pressure, your flow, your consumption, and quality. Yeah? 1 minute. All right. I'll just give you some dashboards. So you can see here is your dashboard to monitor the entire network. Here is a dashboard for a DMA. I'll quickly go through this. You can visit our booth. It's at the end of this hall and look at the system real time. But here you can see some of these use cases. Yeah. So here you can see it's the planning and operation, real-time operation compared to the simulated HMS data. Well, we don't have time for this, but maybe I'll just give you a 1-minute brief. We also tried to do an intelligent burst detection system based on our NPM. So as I said, we also have an artificial intelligence. So we implemented a machine learning model within our platform to detect the bursts. And what we do is that we try to handle it from the perspective of the existing system. So normally you have the data source, so you have the hydraulic modeling, and you have the anomaly scenarios, which is sort of your data source for the machine learning model. And then you have the real-time data, which is the SCADA system. It is going to the prediction models, the UNA, which predicts the real-time information. And then you do a pattern matching of the anomalies that are coming in. So we implemented this. These are some dashboards that you can create, but let me come here. We implemented these solution in a district in Dubai to see if we are able to localize the bursts. So for your context here, we have implemented now, for example, good, medium, and bad. So if we have 4 out of 5 pipes in a network from the simulated data source are matching with our existing readings that is getting from the SCADA system, then you can say that this is a good detection, and so on, medium, and bad. So in this situation, we have, let's say, 609 pipes in one area, okay, but we have only 4 useful sensors that are already installed. And based on the pressure of those sensors, we have to map out the characteristics of each of the pipe. How does the pipe react when there is a change in the pressure, when there is a leakage? So this is some examples. As you can see, for example, there is a pipe number 1 and pipe number 18. They look similar. Pipe number 2 and pipe number 3 look different. So this is some examples of the burst. So the HMS system is creating a burst on each and every segment of the pipe, which is then going as a reference for the machine learning model to look at the real-time readings that are coming from the SCADA system and then match these to this reference and give you the exact location. And since you have already the GIS information, you can pinpoint the exact location saying, okay, this is here where my leak is. So, for example, we have pipe 8, so we can see that we have segments of small pipes, and there is an example of a good match. The red is actually the burst, the actual burst, and the green is showing what the model has predicted. So you can see that it is very close by. And then, for example, here you can see that the red was the leak was somewhere there, 60 602, pipe number 602, and the top 5 pipes where it might be a burst is shown here. Yeah, for medium, you can see that the red was the leak, but it showed you a little bit far away. And similarly, for a bad match, where we say, okay, it predicted very far away from where it is actually the leak is. Overall, the model from these 609 pipes, we see that we have a cumulative accuracy of almost 86% of good. So that means 4 out of 5 match is happening at 86%. And we have a cumulative accuracy of good and medium at 91% and only 9% bad accuracy. That's not it. That's not it. That's not the end of this, this presentation. If we go back here, what we said is that we said whenever the system makes a bad prediction, we have this feedback loop where you say, okay, that was a bad prediction. So the next time when the system is looking at this kind of information, when it is looking at this kind of real-time data that is coming from the SCADA, it knows that, okay, the operator told me that this was a bad match, and it should then recalculate its AI to detect the leak. Yeah. So that was it from my side. Thank you.
Thank you so much. This is Dr. Rıfat Kurban from Turkey. I am an assistant professor at Computer Engineering Department in Kayseri University. I have graduated from computer engineering. I have master's and PhD degrees and postdoctoral degrees from the department also. And also I have a second master's degree in integrated water management from Ankara University. I am also a supervisor of a small startup that produces SCADA and water management software and some remote control devices. So I want to talk about automation of urban water management systems, and if I have time, I will give you a machine learning example. As you may noticed, 3 weeks ago, an earthquake hit Turkey. So at least 50,000 people dead, and over 10 million people are affected heavily from the earthquake. My city is 150 kilometers from the earthquake's epicenter. We have shaken very badly. There is no damage in my city, but as you know, I am deeply sorry about this. I hope the necessary measures will be taken. As you know, we have surface water and groundwater, and we use submersible pumps to obtain the groundwater. And if needed, there is a purification facility, and we collect the water into tanks and send back to customers by using the water pipe network. And we have two dangers. One is the inefficient pumps. If you are using pumps, the most valuable thing is the energy cost. And the second one, the high leakage rates in the water network. We do not know the extent of the danger because we cannot measure it in general. Current status of the problem one. In Turkey, we have obtained that inefficiency of the pumps used in water supply systems is around 25%. You can see pumps flow and head graphics. It's the performance graphic. As you see, a pump operates at 85 cubic meters, and with the head of 65 meters, and with the pump efficiency of 77. But if you operate this pump in working like this condition, 120 cubic meters per hour and 35 meters, the efficiency drops from 77 to 50%. But if you operate also this pump in 30 cubic meters with the head of 95, also the performance is decreased. So there is a best efficiency point. So you have to run the pump in the best efficiency point. The graphic on the right-hand side is the typical distribution of the total cost of ownership. As you see, initial cost is very, very small in the total distribution of the total cost. The blue is representing the energy cost within in the 10-year period of the usage of the pump. Okay. And the second problem, also in Turkey, the water loss in urban water distribution is over 40%. It's a huge number, you know. It's a huge number. We have to decrease this value. How can we solve these problems? We can implement SCADA and automation systems at the end of this pyramid. On top of it, we have to implement energy efficiency and water efficiency techniques. And on the top of this pyramid, we have to implement business intelligence. We have to implement smart dashboards, as Mustafa said. And we have to integrate management information systems. We have to integrate SCADA with the CBS and other things. How can we make energy efficiency? We have to measure all of the pumps that are operating over 10 kilowatts per hour. If we sense if we detect that pump is inefficient, we have to replace that pump immediately, because, as I told you before, the initial cost is very low. Or we have to use variable speed drivers to operate to move the best efficiency point of the pump and operate more efficiently. What we have to measure in order to monitor the health of the pumps, we have to measure the groundwater level in deep wells by using hydrostatic multi-level sensors. And we have to measure the pressure of the pump, the inlet pressure and the outlet pressure for the booster pumps. Also, we have to measure the flow by using flow meters, electromagnetic flow meters, or ultrasonic flow meters. And we have to also measure the energy consumption. We have to measure all four these sensors, these values. What is water efficiency? We are using, as you know, district meter areas. We divide our network into small pieces and try to understand what's going on and which area is the leakages are higher than the other areas. So we are using pressure reducer valves. We are operating these valves according to the time basis or according to the usage and try to lower the leakages. We are using controllers on site. The controls must support open communication protocols, and they must have built-in data storage, and they must be programmed or reconfigurable structure. And the number of the analog and digital inputs outputs should be sufficient for the application. Also other things. And this is an example automation and management architecture. There are controllers on site. Sensors are connected to controllers. We are using 2G, 3G, 4G, and narrowband and LoRa technologies to get the data. We can use OPC systems to integrate because all of the controllers can speak different languages with different protocols, as you know. We have to use SQL databases, and we have to use web-based dashboards and web-based interfaces. These are the software requirements. softwares must support open communication protocols such as Modbus, DNP3, 104, or MQTT, and other things I have said before. There are some applications in Turkey. This is a water well, and the well is operated with variable speed driver. It also makes energy efficiency. Also, the quality of water is sufficient to drink directly, so there is no purification needed. So we can manage the pressure by using the variable speed driver. By using this, we can make also energy efficiency, and we can also prevent the leakages. We can use web-based screens to collect data or visualize data. As you see, we can see the underground water level, the pressure, the flow, and the energy consumption. So we can easily calculate, as you know, there is a gauge there. We can easily calculate the efficiency of the pump. And there is another application for non-revenue water reduction. These are solar power operated stations. They are buried in the earth, and there are flow meters. I think this one is an ultrasonic flow meter and a pressure sensor. And there are interactive maps, pressure maps, or minimum night flow maps, or leakage maps, etc. And this is an interesting application. It's a very compact pressure valve controller. It has an actuator on the pilot of the pressure valve controller. This is for DN, 150 millimeter diameter, and the whole length of the system is only 110 centimeters. So you can use this system in very compact areas. This is an example in Konya, in Turkey. It's a major city in Turkey. The bypass line, as you see, the authority also used pre-built concrete blocks. And this is the result before using. The red lines are the pressure, input pressure and output pressure, and the green line is the flow meter. As you see before the application, the average consumption is around 60 cubic meters per hour. After the pressure regulation, it is dropped to 45 cubic meters per hour. We have saved 15 cubic meters per hour, 360 cubic meters for a day, and over 100,000 cubic meters per year. If I have time, Chair, for 3 minutes? 5 minutes. 5 minutes? Okay. Okay. Let me show you an example of machine learning, because I am studying on that area in the academic way. As I told you, the pumps are operated. We don't know if we are operating a pump in the best efficient point or not. The SCADA operators are not mechanical engineers, mechanical professionals. They cannot know if the pump is operating on the best efficiency point or not. So I tried to make a simple prediction algorithm that can be integrated to any SCADA if the flow and pressure data comes from the SCADA. I have tried to accomplish this. Can we estimate the ideal energy consumption using the flow and pressure of a running pump? The model accepts flow rate and head meter, and gives the output, the ideal pump efficiency, motor efficiency, or ideal power consumption. So the operator can easily compare if that pump is operating in the right point. Okay. So we have collected data set. We have made some tests in our lab. We can collect some data from catalogs. Also, we have made some field tests. This is an example of small example of our data set. The pump labels and the head meter, the flow, the operating frequency, and the power consumption. This is the overall system. The operator can see if the pump is operating at the right point or not. We integrated our artificial intelligence model in Microsoft's Azure platform. As you know, Azure is a cloud-based machine learning service. Your artificial intelligence, AI intelligence model runs on the cloud, and it can be integrated to the SCADA system. This is the model I have created on Microsoft Azure. This is a free service, I want to inform you. And the P1 is the actual power consumption, and the scored label is the prediction of a machine learning model. As you see, the correlation is very high. So we have integrated this model to a working SCADA system. This pump is operating at producing 90 cubic meters per hour with the pressure of 123 meters head meter, and the power is measured, the real power is measured 75 kilowatts per hour. But our model says that you have to consume only 51 kilowatts. So the operator simply thinks that if he is or she is not even in a professional in that area, he knows that over 20 or 24, 22 or 20 is wasted over there. What is the meaning of this? If we also our system proposes the right pump, chooses the right pump. It says 5 dash, I cannot read from here. 10 is the suitable. If you use this pump, you will gain 20 kilowatts per hour. It's a huge number, you know. The total investment will be returned in only 75 pump. Thank you for listening to me.
This has kept almost to the time. So now we have something about 15 minutes for questions and answers. I start with the gentleman over there. If you like.
Very, very interesting lectures and presentations. You know, we all try to move into the fourth industrial revolution, Internet of Things, cloud computing, and you know, artificial intelligence and these things. And we all believe in smart water management. And you are providing us with a very nice tool for that. Now, I'm observing this emerging trend. We still see in the Arab region there's a reluctance in getting into that thing. And I really don't know. I would like to have your opinion on why this is late. Is it so much delay? Is it because there's a risk, data to be taken from them? Is it capacities? Is it financial issues? Is it they don't want to be slave for only one system, and the system cannot, really get stuck with it? I just would like to know your opinion about this. Why we are so slow at getting into that system with our water intelligence?
I think we should address
if you like, I can answer. I don't think this is something to do with the Arabic culture or something else. I'm living since 30 years in Germany, and there's some shops we can't pay with Visa card. So it is still a mentality, so it's step by step. And there are some regions that are taking things slowly, maybe, but sure. Which it's not bad. It's not bad. We say digitalization in Germany. We have a developing country, for example. We are not to compare with India, for example, or with the Middle East, it's nothing. So I think it's a kind of culture. It's a development that takes time. But I don't guess we are behind in terms of digitalization. In terms, the example I have shown, this is coming from maintenance engineers. Even they are thinking about such thing, how to create, how to develop, and to make things going easier. But I wouldn't say we are really late in terms of digitalization. Yes, this is my opinion about this.
Yeah. If you allow
I would
me,
like to just to add.
Just to explain my question, I understand all the countries are having scales. I'm talking about using artificial intelligence, cloud computing. We are talking about something much higher. The thing that this guy, Mustafa was saying.
Yeah.
I'm talking about smart water management. I'm not talking only about monitoring. I'm talking about the other two steps that you have shown in your
yes,
Well, yeah. So first of all, I agree with Nabil that yes, everybody is adopting it, and it depends really. So it's not really. It is a cultural thing, and also it's the adoption. But in my opinion, I think the main goal that these utilities or let's say the government has to define is to drive this with the vision. So how is it going to affect the normal consumer? Are we able to bring down the cost of water for the normal consumer? Because at the end of the day, so you said that is it financial? Is it that we are afraid to get stuck with one system, or is it that we are afraid to use only certain parts of the technology? Should it be secure? Is my data protected and everything? So it has to be driven, in my opinion, both from the top-down and the bottom-up approach. So the top-down approach is going to be the good regulation driving this kind of change. So you should have a good regulation for the cyber security, for the data security, and let's say the big moonshot kind of strategy and goals that the government is defining. And then the bottom-up approach is, what difference is it making to the normal consumer? Is he able to get a benefit? If we implement this AI, machine learning, or if we implement business intelligence across a water utility, does a normal consumer benefit from, in which way? Is it a better water quality? Is it a better availability of water? Is it a cheaper quality of water? And when these two things, from the bottom up and from the top down, combine and merge, we will see that the adoption will be much faster. And we're already seeing this in many parts of the Middle East. For example, we are seeing, I live in Dubai, and we have so our systems are being used there in Dubai, and this is already driving this kind of applications, is driving and improving the quality of life. And then the adoption is increasing.
thank you. Please.
Assalamu alaikum.
Wa alaikum assalam.
Abdurrahman is from Saudi Arabia.
Ahlan wa sahlan.
I'm Walid Abdurrahman from Saudi Arabia. I would like to thank all my colleagues for their presentations. Very interesting. To me, these presentations tackles, I would like always to see the small picture and big picture. So some of the presentation, they show us some technologies for leakage detection, and every day we see more technologies and more, and the emerging technologies now we are using fiber optics. So it depends on the economy, scale of economy, the resultant, how much we need to reduce the leakage. We can reduce the leakage below 5, but is it economic to go to that? Is it 15% or 9%? In Singapore they claim 7%. But to me in Arab countries it's not feasible. I might spend billions to do that. So we have to take care of presenting technologies with the relation to the economics behind that. So we have, small pictures, technologies which really I respect. But to me now, since we are talking about smart technologies, I have two comments here. The first one, whatever we do with the smart technologies, we have to connect it to the total picture. Now I have urban water management system, but we cannot isolate this system, the operation of the system, from energy consumption. This is very, very important. And also from developing these cities to green cities and climate change. I don't want just to zoom to, I have a leakage detection, I have smart water, I can discover how much leakage here, I established one of the leading water companies now we use to do urban water management in the city. Now Mayhan Holding is managing northwest and eastern. We use all types, including helium gas and fiber optics and so on. And we use also smart systems. And we started using automation. I want to answer Dr. Walid Zubari. In 1981, we developed the first automation system in the Arab world for the city of Riyadh. They used to operate wells and the reservoirs networks, independently. But we have developed, closed water conduit, and we, connected through remote evaluates, intelligent remote since 1981. And we developed automation for our HISA project, open channel network, multi-hydraulic packages with remote terminals controlling the gates, with messaging support system, how much we have to increase, decrease. So we started in the 80s. In the 90s, Arachi farm in the north, more than 300 wells. We connected through SCADA with satellite to connect the groundwater flow model to irrigation requirement model to distribute it. And Sheikh Islam used to use to see the farm 80 kilometer by 70 kilometer on a screen. When the rain comes, it will stop automatically, it will compensate. So we did this in the 90s, and we start putting this in the support systems for the eastern province, where to put more areas for agriculture or reduce populated areas, industrial zones. But I would like now, my dream is to connect all these technologies in bigger picture. Now we have new challenges. We have a climate change, we have gas emissions, we have energy, we have food. So we have to connect all these smart systems. The artificial intelligence is not intended only to see how much we have to change the pressure here or there. The artificial intelligence is to look at the economic scale of these networks in terms of energy consumption, in terms of its impact on the circular economy, on the wastewater reuse. This is the big picture which I would like to see in these meetings. And thank you very much.
Thank you. Thank you. Let me just give some input from Jordanian experience. First, I'll try to respect to Dr. Walid's question. Why we don't go with a comprehensive, successful modernization solution? I'm talking about Jordan. There are factors that prevented us from doing this. Those factors are not the tools, not the computer programs, not the data loggers, not the sensors. The facts are all networks, unknown networks. It was almost impossible to make a solid GIS for Amman or Erbil or any of the Jordanian cities. Every day we discover old pipes that we don't know about. This is number one. Number two is the lack of water. We are working with intermittent water supply, which means 24 hours per week. By that, we couldn't apply any kind of SCADA to the networks. We installed data loggers, pressure, district measurement points. We installed district metering areas, flow measures, okay? But we couldn't apply. So what the people do, they bypass all this. Because when you pump, they have no money to invest such sophisticated systems on the ground, okay? In addition to that, the staff working on the ground, the staff there, we need one generation maybe to replace the staff by staff who can accommodate working with sophisticated systems. It's not easy for them to work with GIS, with computer, with laptop, this and that. So it needs time. result of that, unfortunately, is very bad. We have almost 45% non-revenue water. We would like to see that dropping down, but we couldn't.
Italy has 40%. Italy has water losses over 40%.
It's also a huge number.
So it's a huge number. So we should not
In Jordan,
underestimate us.
yeah, in the
We are
areas,
doing well in the limited resources.
here, in the areas where we were able to pump 3 days a week, we reduced the non-revenue water. We could do it. You know, now, we see the leak in the street and we can't repair it. You know why? Because the water is pumped for 24 hours, pumping. That means received something about 15, 16 hours. If you close, shut down the water and repair that pipe, the people in that neighborhood will not receive water. So what the technicians do, they put a mark and say, there is a leak here. And they come the second day when there is no water. They don't find it always. It's not always the case.
I have a question for Mr. Mustafa. I'm Ferwas Rabi from Royal Scientific Society. I have good experience in working with real-time monitoring systems, so I want to ask about your systems and your sensors and loaders.
Okay.
You are talking about the dashboards where you can find some KPIs. I want to ask if your software is adapted to your customers' requirements, or it's just software that has been built and you can check A and B and C for the KPIs.
So the software, there is no one software that can fit any one customer.
Yes,
Okay?
that's right.
So it is always a bad idea to say that I will give you one software and it will solve all your problems.
Yeah.
What we do is that the basic, let's say that the models, the modules of the NPM, the software, already have the KPIs that we have developed from various of our experiences. We think this is a good KPI, we think this is a bad KPI. But it doesn't stop there. If you think that you know that this is a KPI which is important from you, you can define it by yourself.
Okay, so there's
So-
that you can add your
You
own
can add your own KPIs
Okay.
and you can monitor each and every aspect, and you can do recalculations within the software. You can
Okay.
pinpoint areas, you can create new types of reports and everything related to
your
your
system is
operation.
working both for quantity and quality?
Correct.
Okay. I want to ask Mr. Rifat, please. You started your presentation about the earthquake that has happened in Turkey last
yeah.
month. Yeah, I want to ask if you are now thinking to have like water and wastewater utilities resilient guidelines, because you are suffering from earthquakes. So are you thinking to have such guidelines to how to be resilient? The water and wastewater utilities, how to be resilient for the earthquakes and to minimize the damage.
Thank you for the question. We have some working points on the area that have been affected by the earthquake. Some of them very near, very close to the epicenter of the earthquake. The earthquake has happened in 4 a.m. In the morning, 4:17. At that exact time, some of the in Gaziantep province, all the connection was gone. So the electricity might be gone, the GSM network might be gone, or the facilities might be crushed. They are very close to them. Some far from the epicenter, we observed that the underground water level made a sudden change about 12 meters on that time, and then after some time, the water has changed over 5 meters. Also, I have measured 300 kilometers from the epicenter. There has been also 25 or 30 centimeters change in the underground water. So the underground is changed by the earthquake to make resilient the water systems. We have to make redundant connection systems. Maybe we can use both LoRaWAN and the 4G network together. But even, especially in this event, the earthquake magnitude is approximately M7.8 or M7.7 and very close to the Earth ground level. So on that time, the water pipes are broken. There are some over 5 meters to 6 meters ruptures on surface. Nothing will resist on that such a earthquake, but we have to make redundant systems, and we have to create emergency situation actions very well defined. So, I would just like to add to that.
Our last question for today.
Thanks a lot for your interesting presentations. Ahmed Faris from Green Math Solutions. One question for Dr. Rafat regarding the energy efficiencies. Your system is, as a monitoring system, will tell the operator that you are running at the best efficiency point for output. But again, just knowing the situation is not enough. Maybe the operator will not reflect to
the officers.
Yes. So I need the system to react, to make the decision itself, to transfer to the, if it is low or high efficiency keep, but it is in the lowest side or the highest side, we have to take decision to run the smallest pump, run two pumps in parallel, do whatever the system can do to keep at least a range of high efficient point for the pump from the both sides. So I don't know if your system allowed to build one like this one.
I can answer this question. Thank you for the question. We know that there is a working system. Even the authority knows the pump is inefficient, but it's a working system. If you stop the pump, the people cannot get water. So even if you know it's inefficient, you may have to wait some time, some spare time, create a spare time, and then you can replace it. I didn't mention in this slide, but we have another optimization model. There are some meta-heuristic algorithms, some optimization algorithms. We have implemented such a model like this one. It can make action in real time. It can obtain the data from the water wells. Imagine that more than 2 or 3 or a pump of groups, group of pumps, sorry, are obtaining water and filling a tank. So the algorithm decides, measures the level of the tank, so then operates and optimizes the schedule of the pumps. This one starts, this one stops, this one operates with the frequency of 49 Hertz, this one operates at 51. The aim is operating all of the pumps to fill the tank, and the main objective is making the energy efficiency. It's an other algorithm. It operates autonomously, but I couldn't include in this slide. Thank you so much for that.
Thank you, Dr. Rafat, and thanks for everybody. I think there are people waiting for this room. There is a problem.
Very quick. Very quick question. Yes, sir.
We have our friend صديقنا عماني قبلك قرب أيضا. Please.
How do you observe? I just have one.
Take the mic.
This is Saud Shilani from water regulations, from water. We have in terms of electricity, we have different tariff in one day.
Yeah.
So that's changed. How that will be interrupted you can customize running this pump or that pump different because we have different tariffs. The same day we have 4 or 5 tariffs, and we have on the season also it's totally different. So you have some kind of arrangement.
Yeah, the questions are real good today. In Turkey, there are also lots of electricity tariffs, and if you implement the price data, as in Turkey, a government authority publishes the tomorrow's tariffs before the day before, and we can with a REST API service over internet, we can connect that API service to our software, and our software can decide between this time and this time the tariff is lower or higher. In the lower rates, we have to fill our tanks. Also, this strategy shows your tank capacities are enough or not. After careful analysis, you have to decide that we have to enlarge this tank, or we have to build more tanks over there, over there, over there.
And the system will give you recommendations.
No, not included in also in this example, but we are also working a similar project that you have told us. Thank you so much.
Okay. Our last question. Yeah, let's quickly.
Thank you. My question is for Mr. Mustafa. Thank you for the presentation. My name is Hisham Shariat. I'm from FAO. There is a lot of projects implemented under the water energy food nexus. And one of the digital solutions proposed here is that farmers can use the solar powered irrigation systems. The other face of the problem is that they are using more water now because the cost of energy is becoming low. And although there is good impact on the environment, you have farmers that are pumping more and more water. You have presented the solution that is the smart metering, but you said that this measures the actual let's say value of water pumped. So my question is that possible in like very in area where there is a limited access to technology, to internet, to electricity, etc. Is that possible to have this kind of solutions combined with solar powered irrigation systems and to include in the model the water productivity component to make sure that these farmers are not using more water, that they are focusing also on water use efficiency in addition to pumping enough water for them?
Okay, yeah, so that's a very good question. Yes, to answer your question short, yes, it is possible. You can use, for example, battery-operated devices where you don't have access to energy, electricity. So you can use battery-operated meters with the communication capability over, let's say, IoT like LoRaWAN or over RF mesh and so on, NB-IoT. That is to get the data from the remote locations, from the solar-powered locations. And the second question you asked is that is it possible in the systems to make sure that they are not overusing the waters? That's exactly what we were saying, is that you can define your own KPIs, and one of those KPI could be that if certain amount of threshold is violated for the usage of water, that could be flagged. And once it's flagged, it is, since you know from which area, from which farmer this is coming, you can implement a policy to fine him for overusing. So that means you're creating a loop where you're rewarding the people for using the water in their allowed limits. And then you create this virtuous cycle where every farmer is then saying, okay, even though the water for me is cheap now, but if I use my water more efficiently, there is a reward for me. And if I don't use it in an efficient manner, I have to pay a fine. So yes, you can do both of these things in the system.
With one comment here, from our experience, you have to safeguard that meter from the farmers because they will damage it.
Yes.
That's your fear.
So that's, I think, my last point here is that you can put as many systems as you want in your networks. You can implement billions of dollars of technology in your networks, but at the end of the day, your system is only going to be as smart as the people who are operating and as the people who are using it.
Yes,
so
yes.
if you are not able to safeguard the meter, why even put a system in first place? Yeah.
Okay, let me thank our presenters, all of them, and thank you to the public, and thank you very much, everybody.